The following presentation is for Nexio's BAT-EMC software. In this example, we will be exploring the conducted immunity test according to the CISPR standard. First off, let's look at the BAT-EMC software. In the center column, we have the equipment list. To perform these tests, we will need the devices such as a CDN or the EM clamps, and we have them populated. We have the equipment tied together using the equipment setups. And if we look at a typical setup, here we have one for the calibration method for the CDN according to EN 61000-4-6. If we look at the signal generation path, indeed you can see the devices in the right measurement chain according to the standard. We monitor forward power, reflected power, and disturbance. The difference between the CDN test and the CDN calibration is that during the CDN test we do not monitor disturbance. Next, let's look at the immunity resources. First off, we have targets that are populated. This would have been done by the Nexio personnel at the onset, but also customers are trained on how to add new targets as well as how to edit them. Another key item has to do with the regulation parameters. Let's look at the one for calibration. You will note that when regulating, we are allowed to deviate about 0.3 above, 0 below, so that we stay on target. Then we decrease the step by 6 dB. We are using fast regulation methods, so the regulation factor of 0.8 means we will then increase the signal by 80% until we are again regulating. Many customers are quite pleased with these options and the ability to configure and optimize. For example, if I look at the one fast, the customer wanted to decrease only by 1 dB in order to speed things up. If you have the equipment that's capable of doing this and maintain stability, then great. Next item would be the calibrations. If we look at the ones for conducted voltage calibration, you can see we have a previous one, and it indeed has data. If I were to look at the data, this data would be usable by future projects. Let's consider this one to be outdated and we can do a new one. I would duplicate it and we can change the date so that we know it is current. I would select OK, and if I double click, we can see a start and stop frequency. Our progression method is %, which is required by the standard, 1%. And we are referencing this setup so that we know we are choosing the right resources. The target for this calibration is chosen there, and you can see that it is 18 volts. The reason behind that is because if we are testing at 10 volts and apply the AM modulation, the level will rise to 18 volts. And by doing the calibration at 18 volts, we are certain that the amplifier and the system can reach that power level as well as maintain stability and linearity. Let's go ahead and click on that line and execute the calibration. Here I can see the block diagram to ensure that the right resources are being chosen, and that would be the cable set that we are using. Next, it is this asset number SC136 for that CDN that we want to calibrate. Okay. The calibration will begin. You can see the levels, and if I were to look at the numbers up above, this is the real-time measurements going on, and these are all corrected values taking into account what would be the level at the transducers. We have a tab for powers and VSWR, and I'm going to pause this and then restart it once the progression is continued. As you can see, we've made some pretty good progress. We can also do things like use visualization options to adjust custom colors for what appears on the graph as well as what goes to the saved file or printer. And now we are complete. Another option is to change the scale. For example, if I chose the Y scale, I could adjust that and choose every graduation, which is what's chosen right now, or every 2 or whatever. Now I will end the calibration and we can move on toward the actual project. Here in the project you can see that we have a variety of tests. We have these tests that were created in a test template, and this project was started from a template in order to ensure uniformity and consistency. If I were to look at the frequencies tab, you can see a start and stop frequency and progression. Indeed, we are choosing the right setup. And as far as the procedure is concerned, open loop, I will now reference the new calibration, and it is going to be the 10 volt level, and I will do the offset so that it will take into account adjusting whatever minor deviations there were above the calibration line. I do not measure disturbance for the test. And regarding modulations, CW is what we level on, and then we apply the 80% modulation, 1 kHz for 2 seconds. Now, just verifying everything is correct, it will be an increasing sweep. I can click on that line and we will simply hit the execute button. Once again, the block diagram will appear. You can see that the resources will match exactly what was done in calibration. I will select OK, and now the test will progress. You can see that we have a 10 volt target here and that we are generating RF. It is following the target. You can see the measured values up here, and if I look at the power tab and the other tabs, you can see that we are tracking the target. Just as before, I will pause and then restart toward the end. As you can see, I resume the test and I'm going to hit the space bar. When I hit the space bar, it will allow me to enter a fault. I will now give it a new name, such as the second dropped packet, pretending that perhaps I'm monitoring an Ethernet cable or something like that. I will select OK to resume the test, and I will carry on in the automatic mode, and then it will finish the remaining frequencies. As you can see, we're nearly done. And there you have it, the end of the test. And we had 2 faults that we simulated as if we detected. I can then end this test. Now that the test is completed, we can generate a report. If I were to right-click on the test and select Report, a dialog box will take me to where the report templates are located. I could choose a report template like so, request open, and then when I do so, it will give me a choice to save the report. I could call it report 1, for example. Select save, and then once I do so, the software will start extracting information and inserting it into the template. I'm going to select cancel, because in this case we already have a report we can view, and I will show that report. And then if I scroll down, you can see things like the faults that were detected, the equipment that was used, various details such as the levels, and I can scroll all the way down and it will show the results in simulation mode. This concludes the Nexio presentation. Please be sure to check out our other presentations on other subject matter, as well as a variety of test cases. Thanks for your attention.